Okay, Assalamu alaikum. Today we have here October-November 23, IGCSE Chemistry, paper 4-2 theory, total time 1 hour 15 minutes and marks are 80. So let's start. Bismillahirrahmanirrahim. Table 1.1 gives the electronic configurations of some atoms and ions A to G. We have the electronic configurations. Answer the following questions about A to G. Each letter may be used once, more than once, or not at all. State which of the atoms or ions A to G could be a noble gas atom. Okay, so a noble gas is a group 8 element and it has 8 outer shell electrons. So any substance bit from A to G having 8 outer electrons will be the noble gas atom. So we can see it is P. 2, 8, 8 in the last shell. Next, an atom of an element in group 6, meaning it has 6 electrons in outer shell. So we have F. Next, an atom with an atomic number of 14. So it should have total 14 electrons, as atomic number is the proton number and electrons number of electrons is equals to number of protons in a neutral atom. So we have to count 14 electrons in the options. So it is D, 284, D. Next, atoms from the same group. From the same group means having the same number of outer shell electrons. So we have here E and A. Their period is different. This is in period 2, this is in period 3 because it has 3 occupied shells, it has only 2 occupied shells. So A and E. Next, a halogen atom. Halogens are group 7. So they should have group 7 elements, group 7. So they should have 7 outer electrons, which is G. An atom of an element which is a good conductor of electricity. So good conductors of electricity are metals. So any substance having 1 till 3 electrons in its outer shell will be a metal, but because it will be from group 1 to group 3. So it can be C. C. A stable ion of a group 5 element. Stable ion of a group 5 element means it should have 5 outer shell electrons. Sorry, 8. A stable ion means it should have 8 outer shell electrons. It should have 8 outer shell electrons. So we only have B as having 8 outer shell electrons. So if you remember, we already chose B in the first part. But the thing is, we don't know really for sure what every one of them is. We don't know. So this can be looking at just its electronic configuration. It could be a noble gas atom, or it could be an ion of a group 5 element, or any group for that matter. Because stable ion means outer shell electrons should be full. The outer shell should be full. It should be having 8 electrons. Next, an atom that forms an ion with a 2 minus charge. This means it should have 6 outer shell electrons because as it is a non-metal, it is in group 7 because group 6, sorry, because group 6 elements have a 2 minus charge. So it will need to gain 2 more electrons to become 8, to become stable. So it should have 6 in its outer shell, which is F. That's it. Pretty long question, but simple. But it required the knowledge of periodic table as well as atomic structure. So it is a good question. Next, cobalt and copper are transition elements. Copper has two naturally occurring isotopes, Cu63, Cu65. Okay. Cobalt has only one naturally occurring isotope, 59 cobalt. Complete table 2.1 to show the number of proton, neutron, and electrons in the 59 cobalt atom and the 65 cobalt 2 plus ion. So for this, we would need to look at the periodic table, cobalt and copper for the proton numbers. So as you can see, copper is 29 and cobalt, we need to look for it. It is 27. 27 and 29. 29 is copper and 27 is cobalt. 29 and 27. Okay. This is a proton number, which means number of protons. So 27, 29. The number of neutrons is mass number minus proton number. So 27, 59 minus 27, 32, and 65 minus 29, 36. Now for the number of electrons, this will be, as it is neutral, it will have the same number of electrons as the number of protons. But as this is a 2 plus ions, means it has lost 2 electrons. So it will have 2 lesser electrons than the total protons. So 27 electrons. Okay. Next, table 2.2 shows that this is a standard question. If you look at the summer, the February, March, or the winter questions, winter papers, this type of question you can see in every paper, every other paper, and it's exactly the same. Table 2.2 shows the relative abundance of the two naturally occurring isotopes of copper. Isotope is this, and the relative abundance is this. We know the formula. Relative atomic mass equals to abundance multiplied by mass of one isotope and add the abundance and the mass of the second isotope. So AR will be 63 times 0.70 because we divide the 70 by 100. Next, 65 times 0.3. We can just add these two to get the uh, atomic mass number. Oh, sorry, mass. We are getting 66.75. There seems to be some issue. 63 is 70% and 65 is 30%. So, oh, we made a mistake over here. This is 63.6. 63.6. So we needed to write to one decimal place, so this will be our final answer. Next is one physical property of transition elements such as copper and cobalt is that they are hard. Other metals such as lithium are softer. This is basically the comparison of group 1 elements and transition elements, the two types of metals. State two other physical properties of copper and cobalt, which are significantly different from lithium. So we know the properties. They have a very high density, and they have a high melting point. There are other properties too, but we need the properties which are physical, not chemical. Otherwise, we could have written variable oxidation states. Next, both copper and cobalt can form colored compounds. Some of these compounds contain water of crystallization. Define the term water of crystallization. And by the way, if you were thinking here about writing the colored compounds thing, you can see they already mentioned it in the next part. So you never get credit for anything already mentioned over there, over in the paper. So define the term water of crystallization. Water of crystallization are we have a hydrated molecule, for example, copper sulfate is hydrated, which has this water molecule over here in this compound absorbed. You cannot see it, but it is absorbed. So the water of crystallization is when the are basically the water molecules present or absorbed by the hydrated crystals. This is what we call them basically because they have water absorbed, and if there was no water, it would be anhydrous. Next, state the color and formula of hydrated cobalt 2 chloride crystals. So just like this, we will write for cobalt also. color and formula. First, write the formula COCl2 and 6H2O. You just have to remember it this way. This dot indicates that the water molecule is around this entire molecule, and there are six. It is basically hexahydrate. You'll find all of this, all from this question in the syllabus, in the periodic table chapter, in the transition elements topic. Now, the color is obviously pink. All of this is pure memorization or understanding. State the color change seen when a few drops of water are added to anhydrous copper to sulfate. Now, make sure you read the question correctly. This was cobalt to chloride, and this is copper to sulfate. These are two different compounds. So they go from white to pink, white to blue. This is a test for water through copper to sulfate. State how this color change can be reversed. So if you heat the compound, the water will evaporate and the compound will lose the water and it will again become anhydrous. So all solutions of copper compounds are blue always. Next, iron is manufactured in a blast furnace. Three of the starting materials added to the blast furnace are coke, iron ore, and limestone. Name the other starting material added to the blast furnace. So other than all this. So you need to be very firm with the chapter of metals and especially the extraction of iron, the reactivity series, the extraction of aluminum, and the names of their ores. So hot air is added because all there is to be thermal decomposition is to be taken place, and so you need a high temperature. And air also provides oxygen, basically. The source of iron in the blast furnace is Fe2O3. Fe2 is found in iron ore. Name the main ore of iron which contains Fe2O3, hematite. For aluminum, we have bauxite, and for Fe2O3, we have hematite. The iron in Fe2O3 is reduced by reaction with carbon monoxide. Yes, the unbalanced simple equation is shown, so you need to remember the entire process and the equations, the balanced equations, and which equation is reduction, which is thermal decomposition, everything, and the name of the products, names of the reactants, everything. So we have two FE on this side, and they haven't given us a blank over here, which means we have to do the entire balancing on this side. So 2 Fe will balance the irons. We have three oxygens over here and three oxygens over here. As we have two oxygens over here and one oxygen over here. So the thing is that we don't have a carbon over here. We don't have a carbon over here. Oh, I missed this. This is basically when iron reacts with the carbon monoxide and it produces carbon dioxide, and Fe when the iron is reduced. This is reduction. So let's do the balancing once again. We have two irons over here and two irons over here. We have one carbon over here and one carbon over here, but the problem is we have four oxygens over here and only two oxygens over here. Hmm. So we can add a two over here, but still, again, need now we need two carbons. So we add another two. And now we have 3 plus 2, 5 oxygens, and here we have 4 oxygens. So a tip while balancing is to always aim, or most of the time, aim to form an even number. So if we have 3 oxygens over here, this will make a total of 6 oxygens on this side. We can add another 3 over this side to make a a 6. Now we have 3 carbons, 6 oxygen, 6 oxygens. So state the change in oxidation number of iron in the reaction in 2. So in Fe2O3, the oxidation state of iron is +3. As you know, there are two ways to look at this. The charges go like this, Fe, sorry, this is the other way around, Fe3 plus and O is 2 minus, so Fe2O3 if you look at the formula. So this should be the oxidation state. Another way to look at it is the overall oxidation state should be 0, adding all of the oxidation states of these two. So 2Fe plus minus 6 because we know one oxygen is minus 2. So 3 oxygen should be minus 6. So Fe will be 6 goes to that side, 6 over 2, 2 ones are 2, 3 are. So from plus 3 to 0 because it is a neutral atom. Next, explain how the change of oxidation number shows that iron has been reduced. The oxidation number has decreased, so this shows that reduction has taken place and Fe has, you need to remember this, oil rig. Oxidation is loss of electrons, reduction is oil rig. Reduction is gain of electrons. So we have reduced, iron has reduced, so Fe has gained electrons. Next, basically they were just asking about the change of oxidation number, so even if you don't write this part, it is good. The major impurity in iron ore is silicon 4 oxide. Limestone is added to the blast furnace. Limestone is CaCO3. To remove this impurity, write two simple equations to show how silicon 4 oxide is removed. For each equation, state the type of chemical reaction that takes place. It's exactly the same thing which I was telling you a while earlier. So equation 1, and this for removal of limestone. So what happens first is we need we need basically calcium carbonate is added. Calcium carbonate first decomposes, thermal decomposition to make calcium oxide plus carbon dioxide. This is called thermal decomposition. Whenever you heat a carbonate compound, this will form the metal oxide and the carbon dioxide. And this will be known as thermal decomposition because it is caused by heat and there is a decomposition. The compound is breaking down into two things. Next is when this calcium oxide itself reacts with the silicon oxide to form calcium silicate, O2, O3, sorry, calcium silicate. And this is the acid-base reaction. This is all purely recall. Iron is converted to steel by mixing it with a carbon and other elements. State the term given to a substance which is a mixture of a metal and other elements. Alloys are the substances. Name one element other than carbon mixed with iron in the making of stainless steel. So we know that iron is made up of carbon and nickel and chromium. So we can write either nickel or chromium. Preventing the rusting of steel is important. State the chemical name of rust. Rust is basically when Fe reacts with oxygen in the presence of water, making Fe oxide, iron 2 oxide, which is basically FeO, because Fe also has 2 plus and oxygen also has 2 minus, cancel. So state the chemical name, hydrated, and it is hydrated by the way, because it takes place in the presence of water. Without water, it cannot take place. Hydrated iron 2 oxide when the water comes in contact with the iron. Steel can be coated with zinc to prevent rusting. This provides both a barrier method and sacrificial protection. So we know there are various methods to prevent rusting. This is the name of the term with coating for zinc. For coating with zinc is galvanization. Next is describe another barrier method for preventing rusting. We can simply coat with plastic, paint, which is done on boards, etc. Explain how zinc provides sacrificial protection. So zinc, this can basically come with any metal which is more reactive than another metal, offering sacrificial protection. So sacrificial protection itself indicates it is sacrificing something, giving off something. So what it is doing is it basically zinc is zinc reacts with the water or with the oxygen, reacts instead of iron or ahead of iron, because why does it do it? Because they were asking about explain, because it is more reactive. You should remember the reactivity series also. Next. This question is about lead 2 chloride. A student a student prepares a sample of insoluble lead 2 chloride. Yes, we know this is insoluble by mixing aqueous solutions of two salts together in a beaker. Identify the two soluble salts suitable for making lead 2 chloride when mixed together. Okay, so we have a chloride ion and a lead. So in any acid, oh, we don't want an acid, we want two salts. So one salt should be containing Pb, I mean lead, and the other salt should be containing chlorine in some way or other. So we just need two soluble salts, and lead has soluble salts. Whenever you're told to choose soluble salts, with the metal you are given, always choose nitrate, because nitrate is soluble with every metal. And for chlorine or choose for the anion, choose the metals sodium, potassium, ammonium. Sodium or potassium is better. Sodium, basically. So lead 2 nitrate plus sodium chloride. What happens really is this is going in the reverse direction, basically. The Na reacts with NO3, the Pb react with Cl. So we just have to choose in such a way that these two react and form this. So even in any other example also, what you should do is choose nitrate with one and chloride with one. Now, what will you choose the nitrate with? You will choose the nitrate with the metal you want to make. You wanted lead here, so we chose lead with the nitrate. And for the anion, we wanted chlorine. So we chose sodium with chlorine. Next, write the ionic equation for the formation of lead 2 chloride by mixing aqueous solutions. Okay, so include state symbols. What we have here is PbNO3. Basically, all aqueous will first we write the standard equation: lead nitrate plus NaCl, and both are aqueous. They're soluble in water. Will produce Pb chloride, which is solid as it is insoluble, and sodium nitrate, which is also soluble. So what will happen is basically all the aqueouses will separate and get their charges. Or maybe I should choose a different color. So all the aqueouses will cancel themselves. We have aqueous. If they are aqueous on both sides, they will cancel. So nitrate is present here and present here in the aqueous state. Similarly, sodium is here and sodium is here in the aqueous state. What remains is this, and Cl. So if you do enough practice, it will be on your fingertips and you can just write the same without even calculating much. Cl minus aqueous will produce basically PbCl2 solid. So if there's a mark for the only product as this means you have cancelled correctly. Next, one mark is for the state symbols and the correct reactant, etc. List the steps the student should take in preparing a pure sample of lead 2 chloride from the mixture in the beaker. Okay, so this is basically the techniques or the methods of separation. So what do we have here? There is a mixture in the beaker, and we have in the mixture an insoluble salt PbCl2. So how can we separate insoluble salts or insoluble substances? We can just filter through filter paper. The residue, the insoluble salt will remain over here on the filter paper as residue. We wash the filter paper with residue to remove impurities. And then as we wanted a pure and dry sample, we will, of course, this washing was done by us, so we have to dry this also. Dry the residue in a warm place. This entire question is basically from acids, bases, salts. This part A. Next part B, it looks like electrolysis. The student carries out an electrolysis experiment on molten lead 2 chloride using the apparatus shown in figure 4.1. Chlorine gas forms at the anode and escapes from the apparatus. Okay, so anode, chlorine is forming, and it is molten lead 2 chloride, not aqueous. Explain why lead 2 chloride needs to be molten before it will conduct electricity. So basically, this is an ionic compound, and what they are asking is basically why ionic compounds conduct electricity in molten state, because they have PbCl2 only has mobile, or mobile basically means which can move in molten or aqueous state. Here molten was mentioned, so we write molten only. Write the ionic half equation for the reaction occurring at the anode. So if you remember, Cl2 was forming, so we have to write basically the ionic half equation for chlorine discharge. So chlorine had gained two electrons, one electron, which is why it was an ion. Now what will happen is it will become a diatomic gas as it is its natural existence, and an electron will be given. Now this is not balanced because there are two electrons over here, two chlorines over here, so we will write two chlorines over here. Now one chlorine gives off one electron, so two chlorines will give off two electrons. Next, state the test for chlorine gas. You need to remember all the tests for the gases. You will find this in notes for qualitative analysis in your syllabus. What we do is we use damp litmus paper, and there is no color change except for, I mean, there is no red blue color change like ammonia gas. It basically bleaches litmus paper. The color goes white. Describe what is observed at the cathode. So we had PbCl2. So Pb will deposit at the cathode. So gray solid is observed because all metals are basically gray except for copper and of course gold. Chemical reactions can involve transfer of thermal energy. State the term used for the transfer of thermal energy during a reaction. This is enthalpy change. Tetrachloromethane gas reacts with steam as shown. The reaction is reversible. The forward reaction is exothermic, meaning it will have a negative enthalpy change. State what happens, if anything, to the rate of forward reaction if the concentration of carbon chloride, tetrachloromethane is increased. What is increased? If the concentration of CCl4 is increased. So you need to remember everything which affects equilibrium temperature with respect to the enthalpy change, exothermic, the reaction being exothermic, or the forward reaction being exothermic or endothermic, and the pressure changes, how they affect the equilibrium. And there will be a question, I think. Yes, there is a question over here. Now, and you need to mention the collisions of the particles. So state what happens. First, we have to state what will happen. The rate will increase or decrease. Then we have to give the reasons. So the rate will increase, we know. If we increase the concentration over here. And this is a question from the rate of reaction, not the equilibrium. The equilibrium shifting is a separate thing and the rate of reaction is a separate thing. So the rate of reaction increases because when we increase the concentration, what are we basically doing? If you know moles equals to N equals to CV, and concentration will be N over V. So what are we increasing? We are increasing moles per volume. So we can write more particles per unit volume. So the collision frequency increases, and there are more successful collisions between the particles, so the rate of reaction increases. State what happens to the position of, so 1 mark for rate will increase, second mark for more particles per unit volume, third mark for collision frequency increases. Next, state what happens to the position of equilibrium. Equilibrium. Now they're asking about equilibrium, reversible reactions. If anything, when the pressure is increased. So when the pressure increase, the side with fewer moles is favored. By that I mean the equilibrium will shift to the side with fewer moles of gas. And when the pressure is decreased, the equilibrium will shift to the side having more moles of gas. So in this case, pressure is increased. So the side with less moles will be favored, which is this side because it has 1 and 2, 3 moles, and that side has 1 and 4, 5 moles. So equilibrium will shift towards left as there are fewer moles of gas on the left hand side and more moles on right hand side. Next, figure 5.1 shows an incomplete reaction pathway for the forward reaction. On figure 4.1, insert the formulae of the reactant and products. Okay, reactants over here. So Cl4, this is basically asking us to label, and products are CO2 plus 4HCl. Next, draw an arrow labeled EA to show the activation energy. So the activation energy is from the reactants to the maximum energy reached because beyond this is where the reaction start and with an upward arrow because it is always positive. Had this been an exothermic, this would have been from the tip, the EA. Next is the maybe the enthalpy change. Yes, to transfer the energy of the reaction. So enthalpy change is this difference. Enthalpy change is this. Negative. Oh, sorry. The reaction is endothermic because the reaction is exothermic basically. Sorry. My mistake. My mistake. The reaction is exothermic. I didn't see the diagram properly at first. If this was endothermic, and they also told us in the beginning also that the forward reaction is exothermic. My bad. My bad. If this was endothermic, this would be the. I meant to show you this. This would be the EA, and this would be the enthalpy change, positive in the case of endothermic, and this is in the case of exothermic. So 3 marks. Define the term activation energy, the minimum energy that the particles which are colliding need to react. So basically, the particles, they collide, but they don't have enough energy that they can actually react to form something or they can form successful collisions. So there is a threshold point, the energy which they need to, which when the energy level of the reactants, when it reaches that threshold point, then only can they react. Okay. So when we increase the temperature, we increase the energy of the particles and it goes nearer or more than the activation energy. And when we add a catalyst, it decreases the activation energy, the minimum threshold or the energy required to react. State one way in which the activation energy of a reaction can be changed. Of course, I just discussed adding a catalyst because the catalyst offers a alternative reaction pathway. So, meaning that they react with a different mechanism. So what happens is they don't need that much energy now. Next, the equation for the reaction between tetrachloromethane gas and steam can be represented as shown in figure 5.2. Table 5.1 shows some bond energies. Use the bond energies and the enthalpy change value to calculate the HCl bond using bond energy and using the following step. Calculate the energy needed to break the bonds in the reactants. Okay, so the total energy here, this is CCl4. So one CCl bond is 340, so there will be four bonds plus four OH bonds. So 4 times 460. So what will this give us? 4 times 340 plus 4 times 460, 3200. You have to show your working, of course. Calculate the energy released when the bonds in carbon dioxide form. So carbon dioxide has two carbon and oxygen double bonds, so 2 times 805, which will give us 1610. Next, calculate HCl bond energy. Now we have to calculate the HCl bond energy, which is this. So the enthalpy change basically is energy needed to energy needed to break the bonds minus energy released. So energy absorbed minus energy released. So we know the enthalpy change, which is minus 130. So minus 130 equals to total absorbed energy was 3200 and total released energy would be, we know this total energy. So we know the energy of carbon dioxide, which is 1610 plus 4x because there are four HCl bonds. HCl bonds are four. Now we just have to solve in terms of x. This will be 1 minus 130 equals to 3200 minus 1610 minus 4x. 4x shifts over this side. 4x equals to, just write it in the calculator. This will go over to that side being a positive. So 3200 minus 1610 plus 130. This will give us 1720 actually, and x equals to 1720 divided by 4, which will give us 430. So what we did was what they told us to. We normally calculate the enthalpy change, which is the energy in minus energy out. So we didn't know over here the complete energy out. We only knew the carbon dioxide bonds energy, and we didn't know HCl. So we made it X, and there were four of this kind, so we made it 4X. And the rest remained the same as we were given this. Any formula in chemistry or in any subject, basically, they can ask you anything to manipulate the formula. Okay, so a homologous series is a family of organic compounds whose members have similar chemical properties. Give two characteristics that are the same for all members of a homologous series. So they have a same functional group. For example, alcohols will always have OH, and there are homologous series. Next is that they have the same general formula. What the general formula means is, for example, for alkanes, it is alkane. This is CnH2n plus 2. So every member alkane, methane, ethane, propane, butane, pentane, hexane, heptane, octane, everyone will follow this formula. Same is for alcohols and everything. In terms of structure, state how one member of a homologous series differs from the next members of that homologous series. So you need to remember the features of a homologous series. So they differ by a CH2 unit. This is basically what you write when you describe a homologous series. Or maybe if they tell you this, they ask you what these members are, what is the relationship between these two members having a difference of a CH2 unit. This basically means that if alkane has this is if methane has this structure C1H2 ones are 2 plus 2 3 because C1H2 times 1 plus 2, so CH3 whatever over here, same over here. So CH3. Now, what is ethene? Ethane. So C2H2 2 plus 2 C2H6. So now this will advance, and what will happen is they both differ by a CH2 unit. For example, if you were to add a CH2 in this, it will form this. Next, A, B, and C are organic compounds. A has a molecular formula this, B is the name tetradecane. Okay. C has three carbon atoms, and it is in the homologous series with this formula. This is carboxylic acid. Name the organic compound, name the homologous series each organic compound belongs to. So A has a molecular formula C12H24. So this is the formula CnH2n. This is the general formula which this substance is obeying. So it is obviously ethene. Sorry, from alkenes. The homologous series we have to write. And we don't need to write the name of this specially, just the series. Part B has the name tetradecane. Ane, wherever you see, that is obviously alkanes. And no other thing is added. Chloro, fluoro, anything else is not here. And C, we already decided carboxylic acid. Pretty straightforward. Name C and draw its displayed formula. So C has three carbon atoms. So if following the general formula C3H, 3 twos are 6, 3 times 2 is 6, plus 1 is 7, COOH. Or this should be, sorry, my bad, this should be C2 because total of 3 carbons. So 2 carbons over here and 1 carbon over here. And again, following the formula, 2, 2 plus 1 equals to 5, C2H5, COOH. This was done to show you that because of this, there will be one less over here because the total should be this. Okay. Now we have to draw its displayed formula, three carbons, everybody containing H, and the last carbon containing the OOH functional group. The formula is propanoic acid containing three carbons. Next is amino acids are a homologous series where each member has a general structure shown in figure 6.1. The R side chain contains carbon and hydrogen atoms only, meaning this is a variable chain in any amino acid. This can be anything. There are different compounds, there are different molecules, which R is. Sometimes it's H itself, so that amino acid is called glycine. You don't need to remember this though. An amino acid has a relative molecular mass of 103. Deduce the formula of the R side chain in this amino acid. Show you're working. Okay, so total molecular mass should be 103. Now for carbon we have 12. For nitrogen we have 14. For hydrogen it is 1. So if we recognize the mass for this, we can minus it from 103. 103 minus this to get R. Okay, so we just have to find this 103 minus how many carbons? Two carbons, 12 plus 12, 24 plus nitrogen is 14, 1, 2, 3, 4. Four hydrogens and by the way, two oxygens as well, 32 because oxygen is 16. So 103 minus 24 plus 14 plus 4 plus 32, which is 28. Okay, so 103 minus 14 minus 24 minus 32 minus 4. Have we written everything correctly? This 15 became 14. This was 29. So this is 29. 103 minus 29 will be minus 103 will be 74. The side chain has a mass of 74. So which means is if it contains six carbons, for example, it should have 72 carbon, 72 mass. So two remain. We can add two hydrogen to get the total as 74. Or so we have to deduce the formula of the R side chain in this amino acid. So sorry. This is what this 29 is what we got after minusing. So this is what we got after subtracting this from this. So this is basically R, MR of R. My mistake. MR of R. So if we have two carbons, this will be 24. Two carbons and five hydrogens, this will be 29. Total of 29. So you have to just do a trial and error, and once you practice it enough, you'll be perfect with this. So the formula will be two carbons and five hydrogens. State the name given to the natural polyamides formed from amino acid monomers. Polyamides mean if you join these more, obviously proteins. You should be knowing this. So we have completed the paper. Thank you. Jazakallah.